Thanks, everyone. So as mentioned, this is our second decade of supporting iGEM. And in thinking about this talk and in thinking about the support that we've had for iGEM, it made me think back about the origins of IDT and the similarities that IDT has to a lot of iGEM teams. And I want to go through that with you guys and talk a little bit about sort of how we started and hopefully maybe give a little pointers or a little something that anyone can learn about how to run an iGEM team or start a business for that matter. So when we think about the origins of IDT, it all starts with one person, and that's Dr. Joseph Walter, or Joe as we all know him, or knew him, I should say. So Joe started the company 36 years ago, and when he started the company, it started in a way that's similar to the way a lot of iGEM teams started. He came up with a little bit of funding, and he had an idea that he wanted to change something about science. The thing that he wanted to change in science was the access to DNA and access to synthetic oligonucleotides. Now, oligonucleotide synthesis has been around since the 70s, and at the time that Joe started the company, you could buy commercial synthesizers and you could make your own oligos, and you could actually make pretty good oligos with them. The problem is the reagents for oligos degrade very rapidly, so if you're not making oligos every day, your reagents would degrade and the quality of your final product would degrade. What Joe thought that he could do was start a company where he could provide low-cost, high-quality oligos to the entire scientific community and enable research in a way that hadn't been done before. So if we jump ahead 3 decades later, or really 3.5 decades later, IDT went from a small building like this, where actually only about half of it was used, to a much larger building like this. You can actually see the small building is still in the little area here, but it's encompassed with a bunch of other buildings. And if we look inside that building, we see synthesizers, rows and rows of synthesizers. And this represents another problem, or a problem that we ran into early on with a company. And the problem was we couldn't get synthesizers that could synthesize the quality and the types of oligos we wanted. So like many iGEM teams, rather than throwing our hands up and walking away, we made our own synthesizers. And what you see here represents the 3rd generation of synthesizers that we have. We're really on the 6th or 7th generation of synthesizers, kind of depending on how you count it now. Unfortunately, our lawyers wouldn't let us show the newest ones. So this is an example of what we have. The other thing that we realized early on is that if we want to democratize oligos, we want oligos to get to everyone in the US, or everyone in the world, we can't be US-centric. So over the years, looks like my map's not quite showing up here, but over the years we've developed research, manufacturing, and sales centers that are all over the world. We're in 4 continents with all of them. So it allows us to get DNA to a lot of people in a lot of different places. All of this means we make a lot of DNA together. So each day we make a bacterial genome's worth of DNA bases and assemble those into oligos and genes. We ship more than 100,000 oligos out to people every day, and we make more than a human exome worth of genes and G blocks every year. And it's this last part, the genes and G blocks, that I find most interesting. When I came back to IDT after my PhD, one of the first things that I started doing was working on our newly developed synthetic biology line. Now, we had started doing synthetic biology back in 2001, but that was stitching genes together by hand. It was very cumbersome, and we only did that for special projects. It took about 8 years to get to a place in 2009 where we could launch full gene synthesis. Since then, we've been able to develop G blocks, we've developed products for CRISPR, and we've even started dipping our toes into cGMP, therapeutic oligos. I'll talk about that more in a little bit here. But the timing for this was really fortuitous because in 2012, iGEM reached out to IDT. And I have to say, when iGEM first reached out to IDT, we were a little leery. It was a big undertaking. We weren't quite sure what this whole iGEM thing was, and we weren't sure how much support we could put into this. And it wasn't until Randy came out to Iowa and met with Joe that they realized that they had a shared vision. Joe had this idea to get raw products out to scientists so that scientists could do more science. Randy has this idea of getting a very different type of raw product out to researchers, and that is all of you. And this idea of developing for the next generation and getting things out to everyone was the shared vision that both of them had, and that resulted in IDT joining in a partnership that's lasted over a decade with iGEM. And that means for the last 11 years, we've been able to offer 20 kilobases of DNA to any iGEM team that wants it. Now, we don't just offer genes and G blocks, we also offer the equivalent of any of the other IDT products that teams might be able to use. So that includes PCR controls, in vitro transcription materials, things for CRISPR editing, making recombinant antibodies, high throughput screening, and of course, gene construction. We keep innovating as well, just like iGEM teams do. And just last month, we were able to launch our new rapid gene service. So this allows us to develop, this allows us to make and ship genes in 5 business days. So when I started back in 2009, we could make up to 500 base genes, and that would take several weeks to ship out. So this is a great advancement since then. And we continue to invest in new technologies and new processes. This is an example of our new synthetic biology hub. It's a new building that we've made specifically for manufacturing and development of synthetic biology products. And this is an example of the latest building that we have, and this supports our genomics medicines facility. So this is a big change for IDT. Getting into genomics medicines means we're not just providing raw materials for researchers, but we're also providing medicines for doctors. And the genomics medicines that we're developing, really fall into 2 different areas. We have genomics medicines that help in the modulation of gene expression, so things like RNAi and antisense oligos, and then we also have products that assist in developing cell therapies, so things that can help with CAR T and other modalities of modifying cells for medical uses. Like a lot of iGEM teams as well, we have a focus on the environment. Now, when we synthesize oligonucleotides, at least using phosphoramidite chemistry, it's all solvent-based. And as we've heard through many talks, solvents are not great for the environment, and we use a lot of solvents. The good thing that we've been able to develop is over the past few years, we've realized that our waste solvent stream is still pure enough that it can be used directly in other industrial applications. So it's not even recycling our solvents that we're using, we're actually putting them back into manufacturing streams so that they can be used by other industries and decrease the amount of solvents that have to be purchased elsewhere. We also do a lot of recycling, we work on energy reduction, and we also use recycling materials in all of our shipping. Now, IDT uses a lot of energy to make oligonucleotides and to make genes. So much energy that even though we're based in Iowa, where temperatures can get into the -30s in the wintertime, we still cool the building all year long, and that means we need a massive amount of cooling power. And to try and combat the effects of the energy that are used for that, we have a massive geothermal grid behind our facility here. And this grid allows us to produce over 300 tons of cooling every year, so it offsets a lot of the costs that we would otherwise have to spend with traditional cooling. We also use recycling materials in our buildings, energy efficient equipment. A lot of my research engineers spend a lot of their time developing and modifying our homemade synthesizers to make them more efficient so that they use less energy and have a lower impact on the environment. And of course, we do things like solar shading and stormwater bioswales and things like that. One of the other common themes with IDT and iGEM is biosecurity. And biosecurity has been sort of a passion of mine for years. But before I even started back at IDT, IDT had helped form the International Gene Synthesis Consortium. And this consortium helps develop new methods and set up standards for biosecurity screening. We've also worked with Raytheon, which is now RTX and BBN, to assist them in developing a screening software that we now use to screen all of our synthetic biology products. And by 2026, we'll use it to screen every oligo and every synthetic biology product that's 50 bases or longer. That allows us to help keep oligos out of the hands of bad guys and help make sure that researchers get all of their materials as quickly as possible. And then finally, we're an active participant in workshops and publications. This is the latest issue of Applied Biosafety, and what you can see on the cover here is actually our second generation of synthesizers called the Zodiacs that were featured along with one of our articles. I'll also note that on Thursday, I'll be taking part in a screening synthesis discussion, and that'll be, I believe, in the big dome at 9 o'clock. So if you guys have time, please come by and look at that. I think that'll be a great discussion that we'll have. So Joe retired several years ago, and when he retired, we became part of the Danaher Corporation. And you might not have heard of Danaher, but you might have heard of some of the other companies that are owned by Danaher, including Beckman Coulter and SciEx, and some of these companies. So Beckman makes a lot of liquid handlers. They make the Echo acoustic pipetter. They also make automated plasmid prep solutions. Some of the other companies like Molecular Devices make colony pickers, and SciEx makes mass spectrometers and capillary electrophoresis machines. So together, the Danaher products really help innovate and help speed up the design, build, test cycle that exists. So much so that if we look at the companies that have received FDA approval, 75% of those companies have used some Danaher product in the development of that product, which means we're helping get faster screening for cancer, we're helping to develop new modalities for medicine, and really helping to make people's lives better. I think it's a great thing. So I want to think and look back at iGEM here, just to wrap up. When we started iGEM, this wasn't the first iGEM, but this was in 2013, and this was in Cambridge. This was what the entire Jamboree looked like. And last year, this is what the entire Jamboree looked like. So it's grown. It's been amazing to see just in this 11 years how much this has grown. And we're really excited to be a part of this. And it's why we're so proud of the fact that we've been able to commit to iGEM, to give the 20 kilobases of free DNA every year to anyone who can use it, and also all of the other products that we have. And it's one of the highlights of my year to come out here and see all of the work that you guys are all doing. I think it's amazing work that's happening, and I'm really glad to be a part of it. So with that, I'll go ahead and wrap up. Thank you, everyone, and I hope everyone has a great iGEM.